VICHAR. I am Santosh, and in this video I am here to explain you commutative property for whole numbers. First of all, we have to recall that what the whole numbers are. So whole numbers in mathematics are represented by capital W and given by 0, 1, 2, 3 and so on. If you discuss the difference between whole numbers and natural numbers, you will see that there is 0, but the natural number does not contain the number called 0. And that is the difference, that is the only difference in natural numbers and whole numbers. We will discuss commutative property for whole numbers with the following cases. Addition would be the first case, subtraction would be the second case, multiplication would be the third case, and division would be the last case. Now we will define the general rule for commutative property in mathematics for whole numbers. So the definition says that if A and B are two whole numbers, then A star B must be equal to B star A. What the main condition is, it is whole numbers, means whenever we will take two numbers, those numbers should come from the set called W, that is whole numbers. Okay, now the first case, that is addition. One more thing that should be discussed here is star. This star may be some confusing for you. This star will be converted into sign of positive in the case of addition. The same star will be converted into minus in the case of subtraction, and the same star will be converted into multiplication in the case of multiplication, and finally this star will be converted into sign of division in the case of division. Okay, first point is addition. So what is the rule for addition for commutative property for whole numbers? The rule says that A plus B must be equal to B plus A. That means we will take two values, A equals to 2 and B equals to 0. Why 0? We can take 0 because 0 is the part of whole numbers, and we are discussing commutative property for whole numbers. Okay, now A equals to 2, B equals to 0. Then what the left hand side is? Left hand side is A plus B. This implies that 2 plus 0, and this implies that 2. Now what the right hand side is? That is B plus A. This implies that B is what? That is 0 plus 2, and this implies that 2. So we can see that the value of left hand side is same as the value of the right hand side. That means commutative property for whole numbers over addition is satisfied. Now discuss second case, that is subtraction. Again we will define rule for the subtraction. The rule would be A minus B must be equal to B minus A if the property is satisfied. Now again we will take two numbers. Let A equals to, we can take same numbers, that is 2 and B equals to 0. It's clear. You can take other numbers instead of taking 2 and 3, but the main condition, the required condition is that those numbers should come from the set W called whole numbers. Okay, now the value of left hand side is what? Left hand side is, that is A minus B. Put the values of A and B here. A is 2, that means 2. B is 0, that is 0. This implies the 2 minus 0, that is again 2. Okay, but right hand side is what? That is B minus A. Put the values here also. What is B? B is 0, 0, and what is A? That is 2, so 0 minus 2. And you all know that whenever you subtract something from 0, the answer would be negative, that is minus 2. Can we say that 2 and minus 2 are equal? No, we can't say it, because in mathematics signs are very important. This is negative 2, this is positive 2. So this is left side to the 0 of the real number line, and this is right side to the 0 in the real number line. So these two, this plus 2 is not equal to minus 2. That means left hand side is not same as right hand side, and this implies that commutative property for whole numbers over subtraction is not satisfied. Now we will discuss the third case, that is multiplication. So the rule for multiplication, that is the third case, is rule says that A multiply B must be same as B multiply A, where A and B both are whole numbers. Now again take A equals to 2 and B equals to suppose 0, then what the left hand side will be converted. That means A multiply B, this implies that A is 2 and B is 0, this will give us 0, because whenever we multiply any number by 0, the result becomes 0. Now the right hand side is what? B multiply A. This implies that B is what? 0 multiply 2, and this will again give us 0. You can take other numbers instead of taking 2 and 3, and you always will get the result to equal of right hand side and left side. That means the value in the left hand side is same as the value in the right hand side. So what we will say? We will say that commutative property for whole numbers over multiplication is satisfied here. Now the last case is, what the last case is? That is division. So the rule for division for commutative property for whole numbers. The rule is A divided by B must be same as B divided by A. Now let A equals to 2 and B equals to again 0, and see the result comes. Left hand side is what? Left hand side is A divided by B, that means 2 must be divided by 0, and that means 2 divided by 0. Now see here, there is a result called whenever you divide any number by the number 0, the result comes is called not defined. That means this is not defined, means what? The divisibility by 0 is not possible. That means this result is not defined. Okay, now what the right hand side is? So the right hand side is what? That is B divided A. Okay, put the values. What we get? B is what? 0 divided by 2, that means 0 divided by 2. Now again a result, whenever a number divides 0, any numbers divides 0, that means we divide 0 by any number, the result becomes 0. So the result is 0. We can see that there here this value is not defined, and here the value is 0. 0 is well defined for whole numbers, but not defined is not a number. That means we can say that left hand side is not same as right hand side, and this implies that commutative property for whole numbers over division is not satisfied. So this was the video. In this video we discussed commutative property for whole numbers, and we discussed this property under 4 cases called addition, subtraction, multiplication and division. And what we show? We show that the case of addition and the case of multiplication was satisfied, but the case of subtraction and division was not satisfied. That means associative commutative property for whole numbers is satisfied under addition and multiplication, but not for subtraction and division.